All right, welcome, friends. I'm sorry that I can't be with you in person today, but I thought I'd make up a quick clip here to make sure you are ready to join your team and work in a partnership after this intro lesson. So we'll see you soon. So we're going to dive right in at Area Under the Curve, Chapter 10. And we have completed infinite rectangles, which you guys have become very comfortable with, though it is long. I know that you know how to do it. We have introduced you to the beauty of antiderivatives to find the area under the curve. And now we're going to add one new layer. Notice that the go formative would be still 1 to 9, so there's nothing really new there for you to do. So if you've already got up to 1 to 9, you're good to go. Do check out the questions in the notes, which would also be very helpful. And do want to make sure that you are aware of viewing the help. So if you click on this link, you'll notice that there are detailed solutions to all of the challenges up to about lesson 4. So all these lessons can be viewed question by question. So I think that could be really helpful for us. And please consider looking at that if you need it. But I am confident that most of you will be just fine with my introduction and then working with your partner. So let's dive in. So we're going to go area under the curve part 2. And remember that there is support there, as I've already mentioned. So let's dive right in. So we'll click through these bits. And here we go into today. So let's just review what we looked at last time. Let's look at what we looked at last time with area under the curve found by using infinite rectangles. All right, and so what we're going to do here is take the function. We're going to take the antiderivative, and then we need to find the constant, which you all did very successfully. We know that when x equals 2, that there is no area enclosed, so that's why we can substitute 2 in for x and set it equal to 0 and then solve for c. And when we do that, we get a constant of 10/3. And when we have that constant, we of course can put it at the end of the antiderivative in place of the constant. We can now determine the area between 2 to 4 because we're simply going to put the 4 in for x. And when we do that, we can calculate, we can simplify, and we get the 8 2/3, which is exactly the same as this guy. And I know some of you love Riemann sums, but seriously, get some help. Stop it. Use antiderivatives. All right, so now what we're going to do is show you sort of another way of thinking about this. And in some ways, what I'm going to show you today isn't really new at all, but it's a more efficient way of thinking about it. So let's see what you think. So the task here is to find the area under the curve of this gray area here from 2 to 6. And we know that the equation is 2x. So one way of doing it is to do it in one piece. And simply put, we would use the trapezoid formula where the base is 4, the height is 4, the base 1 is 4, and the height is 12. And so when you do all that, you get an area of 32. All right. Now we could do it in two pieces. We could think of it as a big triangle, and which would be 1/2 times 6 times 12, which is 36. And then we could subtract from that big triangle this little triangle, this red one right here. And so simply using that equation again, we have 1/2 times 2 times 4 equals 4. And of course, if we wanted to find the area of just this trapezoid-like shape, we take the big triangle and minus the little triangle. So that's one way of thinking about it. So now let's do it using antiderivatives, okay? So this is what we did. We took the antiderivative of this piece, then we set when x equals 0, when x equals 2, the area is 0. So we can use that x value and the y value and sub it in. And in this case, we figure out that the constant equals -4. So now I have this equation at x squared minus 4. And now I'm going to put 6 in for x. And 6 squared minus 4 is 32. And of course, the area of that area is 32. So now let's look at it another way. We could do it in two pieces. We could take the antiderivative of both pieces. So the antiderivative of 2x is x squared plus c, and the antiderivative is x squared plus c. Now notice this time, I'm not going to determine the c value. And I hope we can agree that the constant would be the same for both of them if we're starting at 0, and of course it is, and I guess that's what I did, so fair enough. So if x equals 0, y equals 0, in both cases we have x squared and x squared, and now all we're going to do is put in 6 for x, and we're going to put 2 in for y, and we're simply going to go 36 minus 4. 36 minus 4, which leads to this new formula. Notice that we have the minus 4 here and the minus 4 here. These are the same. So what we're going to suggest, and I'm going to suggest you do, is rather than trying to find the constant every time, is we use this formula here, which is simply the antiderivative of the function to the outer limit of b minus the antiderivative of the function to the lower limit of a. And just to show you what I mean by that is this area right here, we went up to 2. And to be honest, when we were over on this thing, that's the same thing that we did, wasn't it? Like, notice that the value is 4 and the value is 4. So we're going to be subtracting that. And this leads to this formula. So the area can be found by taking the antiderivative, plugging the outer boundary in, and then subtracting it from the antiderivative with the lower area. And that's exactly what we've done. And that's what we're going to have you practice today. And you can, of course, still find the constant, but it's essentially the same thing anyway. So many of us will probably choose this method. Okay, so let's see if we can walk through one together right now. So I'm gonna walk you through this guy first. Okay, so here we go. So what I'm gonna do, maybe what I'm going to do is I'm just going to compare first. I just want to remind us of what we had here. And I guess we did that to start off with. Notice in this problem, we looked at it earlier. We take the antiderivative, we try to find the constant, and the constant, when I place 2 in for x, I get an area of 0, so I can use that to find the constant of 10/3, and then I work it through and I get my area of 8 2/3. So now, let's go back and try it a different way. And you can decide. There's lots of ways of thinking about this. So I'm going to take the antiderivative. I'm not going to worry too much about that constant because we know that when we subtract the antiderivative from the antiderivative, the constant will be the same in both cases and will cancel out. So notice here, I'm going to have c minus c. Notice that this antiderivative is exactly the same. The only difference is that the b value is 4 and the a value is 2. And so when we do that, notice that this guy here is still going to be our 8/3 minus 6, which is exactly what we had over here. Sorry, Michael, just going to back you up there a little bit. Where did we show that? Yeah, the 8/3 minus 6, exactly the same as our 8/3 minus 6. So it is the same idea. There's nothing new about it. And so that should be enough for you now to work in your partnerships. So whoever you are sitting beside is your partner. Please stand up now. Go to the whiteboards and try challenge 2, challenge 3. And let me just show them to you real quick. So this guy here, you're going to be finding the area under a sine curve. Okay, and then we're going to be shifting gears to this time. They're going to just give you an equation. So you're going to need to draw that, be able to sketch that well. And then we're going to do the same thing here where you're going to have to sketch what that thing looks like. And of course, drawing a picture is very important here. So we'll leave it at that. And there might even be one more. Yeah, I think this is challenge 5. Find the area between 0 to 2 pi. And I notice that sometimes the curve is above and sometimes the curve is below. So you're gonna have to think about how you might play with that, and that should do it. So remember, if you want to see help for these videos, there's a detailed solution to each question. So we're gonna leave it at that, and I will see you soon. Have fun today, Kate.